Okay, very good morning. So let us discuss about microcontroller, that is 18EC46. So we are dealing with the model number 4, but before starting with model number 4, let us have a brief outline of all the modules what and all we discussed till today. That is model number 1. In that we discussed about the differences between microcontroller and microprocessor, then different types of microcontrollers, then architecture of microcontroller, that is 8051. In this particular subject we are mainly concentrating on 8051 microcontroller and its architecture, pin diagram, input output ports, etc. And about memories also we have discussed. Next, let us discuss about module 2. In this we have discussed various instruction sets which are involved in 8051. It may be addressing modes, data transfer instruction, arithmetic instruction, logical instruction, bit manipulation instruction, and with many examples of programs, assembly language were discussed. Next, in module 3 we discussed about 8051 stack and input output ports interfacing, and some of the assembly language programs, and I already shared many videos with respect to the programming examples and the explanation also. Interfacing simple switch of LED input output ports, this is one of the example program. So now presently we are discussing with module number 4, that is serial communication 8051. We already discussed about 8051 timers and serial ports, which the data has been shared in the previous classes. So in this session we are discussing about 8051 serial communication, what are the basics of this, and RS-232 standards and 8-pin RS-232 signals we are going to discuss. Some of the programming examples we will discuss in the later classes. Okay, so let us come back to the actual things. So that is model number 4. The second part, half of the portion is already done. So that is 8051 serial communication. So before going to discuss about 8051 serial communication, let us have a difference between serial versus parallel communication, how it will be done. So here in the left part we have a serial transfer where the sender will send a data to receiver on a single channel. Here the data will be transmitted like each bit at a time, like if there is an 8 bit of data, so bit by bit the data will be transmitted from sender to receiver. Next, in parallel transfer, if the sender is transmitting a data to receiver, that is it is having 8 bits, it will be transmitted simultaneously. All the 8 bit will be transmitted simultaneously. Okay, as we have shown D0 to D7. This is various, that is series versus parallel transfer. Okay, so now I hope you understood about the difference between parallel and serial communication. So next we'll discuss with another thing. Yeah. So in this slide we are going to discuss the serial communication and parallel communication with different descriptions, that is particulars. For example, in parallel communication we have, it is having often 8 or more lines which is of wire conductors and which are used to transfer the data, and as I already told, the multiple bits are transferred at a time. Because it is having 8 channels, it's going to transmit the 8 bits at a time in a single time simultaneously. But in serial communication, the data is sent one bit at a time on a single line. We call it as a wire. Okay, if the set of wires is called as bus. Okay, that also we know. Next, in parallel communication, it is preferred for short distance communication. Because why it is preferred for short distance communication? Because all the data will be transmitted simultaneously. It requires more number of wires, which will create, if we use it for long distance communication, the complexity will be high and the cost will be very huge. Okay, in serial communication it is preferred for long distance communication. As I already told, the parallel communication is costly as more resources are involved in construction. In serial communication, it is comparatively cheap with respect to parallel communication. The speed of data transfer will be very high in parallel communication. It will be slow in serial communication. The example for parallel communication is SPI, Serial Peripheral Interface, I2C, UART, Universal Asynchronous Receiver Transmitter, and PCIs. Okay, Program Controller Interface. So now let us discuss about the basics of serial communication. In serial communication, it uses a single data link to make it much cheaper and enable two computers of different cities. As I already told, it is for long distance. If you want to communicate or if you want to establish a connection between two different cities, so we'll go for serial communication to communicate over a telephone. A byte of data must be converted, and how it will be done. The data, or a byte 8-bit of data, will be converted serial bits by using serial in parallel out shift register and transmitted over a single data line. At the receiver end, the reverse process will be done, that is serial in parallel out. During the transmission, parallel in serial out shift register will be used. At the receiving end, we'll use serial in parallel out shift register. If transferred on a telephone line, it must be converted to audio tone by modem for short distance. Next, here in this slide we are going to discuss different modes for serial communication. Here there are three types, that is simplex, duplex, in that half duplex and full duplex. In simplex communication, serial communication, as the diagram is indicated, here we have a transmitter, here we have a receiver, only one single wire. That means it is a one way of communication. Only a transmitter can send data to a receiver. The best example is like you can take printer. Okay, so simplex communication. Duplex communication, what happens is both transmitter and receiver can be able to send the data. But in half duplex communication, what happens is the transmitter and receiver both is can able to send the data, but not simultaneously. That means once transmitter is sending, receiver has to receive. Once receiver is sending, transmitter has to wait for it and receive. Okay. In full duplex communication, what happens? Both transmitter and receiver can send the data simultaneously, because you can see there are two wires here. But in half duplex, we have only single wire. So that is the difference between half duplex and full duplex. Both are, that is transmitter and receiver can send data simultaneously, send the data, but not simultaneously in half duplex, simultaneously in full duplex. Okay. And simplex, I told, it's a one-way communication. It only can able to transmit data. This is the important basic of serial communication. Next, same thing in simplex transmission, computer only can send the data, therefore it is a one wire. If the data can be transmitted and received, then we'll use a duplex transmission. In duplex transmission, we have half and full. That is depending on whether it is data is simultaneously or not. As I already told, if it is simultaneously, full duplex. If it is not simultaneously, it is half duplex. Okay, that is only one way at a time is called half duplex. Two way at a time, that is simultaneously, it is a full duplex. Next, basics of serial communication. Here we have two types of serial communication. One is synchronous, another one is asynchronous. In synchronous method, what we have is the transfer of block data, which is the characters at a time, will be done. The events are referenced to the clock. And here the example is PCI bus and I2C bus. In asynchronous communication, the method transfer a single byte at a time. There is no clock. The bytes are separated by the start bit and stop bit. Example is universal asynchronous receiver transmitter. Okay, this is the difference between asynchronous communication and synchronous communication. Next, to support serial communication, special interfaces are built in the microcontroller. The microcontroller uses a special IC chip called Universal Asynchronous Receiver Transmitter and USART, that is Universal Asynchronous Receiver Transmitter. This 8051 chips has a built-in UART. That means in serial communication, if 8051 want to support, it should have a built-in microcontroller chip, that is USART and UART are essential. Data framing in asynchronous serial communication. Data is transmitted as zeros and ones. To have a sense of synchronization between transmitter and receiver, and to have a sense of the data, the transmitter and receiver agrees on a set of rules, that is protocols, which describes as how the data is packed, how many bits constitute a character, when the data begins and ends. Okay, that is how the data is packed. That is the one criteria. Then how many bits constitute a character. when the data is begins and when it is going to get end. These are the important things. Next, as I already told, an asynchronous serial communication is having a start bit as well as stop bit. Each character is placed between a start bit and a stop bit. That means for each data which is going to be transmitted through asynchronous serial communication is prefixed with start bit and it will be suffixed with stop bit. This is called framing. The start bit is always a 1 bit and stop bit is always 1, 2 or 1.5 bits. In 8051 serial port where there is no transmission, the transmission line is held high, it is called as mark. The start bit is always 0, that is low. Stop bit is always 1, that is high. LSB is sent out first. So it is important point. The start bit is always low, that is nothing but 0. Stop bit is always high, that is 1. And always the lower significant bit is sent out first. Okay, now let us discuss about data framing in asynchronous serial communication. Okay, the framing of ASCII, as I already discussed, in asynchronous serial communication we have a stop bit and stop bit in a framing. Okay, so here you imagine a data of 8 bits, that is D0 to D7, which is having 0 1 0 0 0 0 0 and which is prefixed with start bit and suffixed with stop bit. Okay, as we are indicating it, it is the start bit is indicated as 0 and stop bit is indicated as 1. So in a frame, if you consider 8 bit of data, so this is start bit and stop bit, both are 2 bits, totally comprises of 10 bits. Okay, and this is going to go out first. As also discussed, the LSB is going out first, so D0, and this is going out last, that is stop bit. The transmission begin with the start bit followed by LSB, then rest of the bits until MSB D7. The finally one stop bit indicates the end of the character. When there is no transfer, the signal is high, which is referred to as mask. That means if there is no signal to send or transmit a data, it will indicate it as high, which is indicated as mark. Okay, that is one. Next, assuming that we have transferring a text file of ASCII character using a one stop bit and we have total 10 bits for each character, that is equal gives 25% of overload because 8 bit character with 2 extra bit, total 10 bits. In some systems, in order to maintain the data integrity, the parity bits of the character bytes is included in the data frame. UART chips allows the programming of the parity bit for odd, even, and non-parity option. Parity means we already know that it will check the number of ones and zeros in the digital bits, that is binary numbers. If it is a 8 bits, let us say we have the example of 2, so it will be having only one number of ones. We call it as a odd parity. If there are two number of ones out of 8 bit, we call it as a even parity. Okay, next, the rate of data transfer in serial data communication is stated in bps, which is nothing but bits per second. Another widely used terminology for bps is baud rates. Okay, bits per second. Another terminology which we are going to indicate is baud rate. It is modem terminology and it is defined as number of signal changes per second. In modems, there are occasions when a signal changes of signal transfers several bits of data. As far as a conductor wire is concerned, the baud rate and BPS are same. That means if you take an example of conductor wire, both baud rates and bits per second are same and we use the terms as interchangeably. The data transfer rate of a given computer system depending on the communication ports incorporated into the system. For example, IBM PCs XT could transfer a data at a rate of 100 to 9600 bits per second. Okay, next. Let us discuss the next topic which is very important in serial communication, that is RS-232 standards. It's one of the important and famous topic in Viva also. An interfacing standard. It is called as an interfacing standard. which was set by Electronic Industry Association, which is short form, it is called EIA, in 1960. An interfacing standard RS-232 was set by Electronic Industries Association in 1960, and the RS-232 is one is represented by -3 to -25 volts, while 0 bit is represented as +3 to +25 volts, making -3 to +3 undefined. The standard was set long before and the advent of TTL logic family. Its inputs and output voltage levels are not TTL compatible. TTL compatible means transistor compatibility. Since 8051 microcontroller will not compatible with TTL logic, so we need a converter which is called as a MAX232, which is of an IC. A microcontroller system must make use of voltage converters such as MAX232 to convert the TTL levels from RS level or vice versa. So the MAX232 chips are commonly referred to as line drivers, which are commonly found in microcontrollers, that is 8051.